So, we continue from what we were talking about. So, we said the loading time is Tq, right, and this is also equals to unloading time, and this. So, this is loading time. Unloading time, right now I am not really bothered. If I take it reverse direction, then I will take unloading time as well. So, Tq is the time for loading. Maybe for one passenger I can find out, multiplied by q, and I can find out for others. We will see that. Then once it is get loaded, this is the loading time actually, total passengers up to capacity got loaded. Then it starts accelerating, right, lifts up, then might be accelerating, comes to a constant speed and decelerate, and then it stops, maybe stops at next floor, but then do not stop at many floors because it is random. It can stop at some other floor, then some other floor, and something like this, and then while coming back, it unloads the passengers, it comes back, comes straight and opens up. So, cycle is something starts from here to this is the total cycle, and we call it round trip time, this is a round trip time. So, round trip time, it starts from first loading all the passenger, then it between every stops, what it does, it accelerates, goes to a constant speed, then decelerate, stops. I will have a door opening time, then people will get out, some people, then door closing time, and then goes up to the next level and next level, etc., etc. So, there is two times available, one is the loading time, one is door opening time and door closing time. So, door opening time and door closing time, let me call this TO and TC, TO and TC. TC is the closing time, opening time, right. So, how many times now this S, this stops, number of stops I call them as S, number of stops are S, S is the number of stops are S. This is somewhat probabilistic. This will depend upon, for a given lift, this will depend upon the people that have boarded. For example, all of us boarded, let us say, and some of you want to get down at 3rd floor, then some of you want to get down at 5th floor, and next time when it making a trip, some people want to get down at 2nd floor, some down at maybe 5th or maybe 6th or whatever it is. So, this is not same every time, it does not stop at every time, right, at general situation. This stop is S is somewhat probabilistic, it will depend upon the people who have come in. Maybe some out of 16 capacity, 16 people who can board, right, all 50%, 8 of them go to 5th floor one time, sometimes some of them go to 2. So, it is a number of stop is actually probabilistic, right. So, S is the number of stops, I call it S number of stops. Now, how many time the door will open and close? S stops, S time it will close, and it will close at the bottom once, and also like there will be S plus 1 time, because the ground floor lobby stops are above the ground floor lobby. So, S number of stops at the ground floor lobby. I am starting from loading time, that means it has opened now and loading. So, now S first it closes at the ground floor and stops at S number of stops including the top floor S, there may be somebody at the top floor or may not be. So, I am including that. So, S number of stops including the total floors above, plus 1 time at the ground floor it would have closed. So, S number of stops it would have closed and it would have opened coming back again onto the ground floor. So, there will be total number of S plus 1 number of times door opened and closed, because at the ground floor it will open and close definitely depending upon where I am starting from my cycle, but S number of time also it will open and close. So, open and close S number of times, it will accelerate same number of times, because it will have to accelerate the ground floor and S stops, and decelerate also same number of time, right, same number of time it will decelerate, right. What will all we are assuming is that acceleration and deceleration is same while going up or coming down, the times are same. So, S plus 1 number of time it will accelerate, is to decelerate, and then in between it will run at constant speed. So, all this time let me define now. Round trip time RTT comprises of time of transfer of q passenger into and out of the lift car, I call it A. Time to open and close the door s plus 1 was 1 time, that I call it B. Time to accelerate, run at contract speed, which is the constant speed actually, and decelerate and level the car s plus 1 time. So, there is an acceleration and deceleration, that will be also s plus 1 time, I am calling it C. And time to travel the remaining distance at contract speed. Lift speeds are actually specified. You will find that it is okay, lift may not, in the board within the lift they may not write the speed, but manufacturer provide the speed at which it will travel when it is travelling at constant speed. So, that we call as contract speed, could be 1.5 meter per second, etc., etc. So, the remaining distance other than acceleration, distance, deceleration, it will actually travel at constant speed, right, and that let me call it as D. Now, this all the time lift may not go to the top floor, it may come down at some level. So, let us say this is also probabilistic. Only when we find one person belonging to the top floor, then only it will go to the top floor, otherwise it will empty every people and then simply come down. So, this H is called highest floor of reversal, H is called highest floor of reversal, height of highest floor of reversal, and highest floor of reversal is also probabilistic, because it depends upon chance factor. I have to find out at least one person in the top floor, so that it goes to the highest floor. So, two things are actually round trip time consists of all this A, B, C, D time and E time, right. E is then express run downward. So, A, B, C, D time, this is the round trip time, will be sum total of all these times, and basically two things are probabilistic here, one is the S and another is H. S is probabilistic. Just to look at the speed typical, we define something called one floor jump time, right. So, basically one floor jump time is, supposing it is only the floor height, distance df is the one floor height, df is one floor height, this is the distance one floor height, let us say height of a floor, distance of a floor, then it starts, accelerates, then comes to a constant speed, right, it comes to a constant speed here and then again decelerates. So, this will be the typical time required, some acceleration time, some deceleration time, right, and constant speed time. Okay. So, this we know, this speed is we know, and it starts from 0 velocity to this velocity, I mean this constant speed, and reduces on an average it will be v by 2, speed we can take as v by 2, and that is what is done, s equals to ut plus half f t square, the distance is equals to ut plus half f t square. So, if you know the rate of acceleration, or you can this comes, I mean basically you take v by 2, the average speed during this time is v by 2. So, you can use this kind of formulae, or simply v by 2 is the speed, average speed here. Some information should be available to its time of acceleration, some information or distance required for acceleration, that should be available to you. Starting u would be 0, in some cases this would be there, but finally the velocity, final velocity will be 0. So, because v equals to u plus f t. So, one can use these formulas to find out, but as basically the knowledge is, I mean basically the idea is this, that it accelerates, goes to constant speed. So, let us see how we calculate out round trip time. A, B, C, D. So, A is the time for boarding, T passengers, Tp let us say is the passenger boarding time for 1. So, Q into Tp, Q passenger boarding, this is for disembarking Tu, so Q Tu, S plus 1 T0 plus Tc, door opening time and door closing time. We said it will open and close S plus 1 time, 1 at the ground floor lobby plus S stops, S probable stops. Then S plus 1, okay, this is becoming, this is slightly, let us say S plus 1 time, it will accelerate, right, it will accelerate. So, if I combine one floor jump time, then something like this, let us say something like this in this diagram. If this is one floor jump time, here one floor jump plus some additional floors where it will run at constant speed. So, how many floors shall I take floor? One floor jump, S plus 1 would be there, because 1 is also ground floor, it will accelerate and decelerate. And if the floor heights are all same, then I can take one floor jump time including the ground floor, So, that is what we have done, that is what we have done, that is what we have done, that is what we have done. So, one floor jump time I am taking, one floor jump time plus H minus S, S is the number of stops, H is a, while going up, H is the probable floor of reversal, right. F minus S, H minus S, if I that would be, that distance it would travel at constant speed, that distance it will travel at constant speed, and H minus 1 that would travel at constant speed while coming down. So, while coming down, right, this is everything is in. So, time to travel through one floor in constant speed is Tb. Tb is the time to travel through one floor at contract speed, and Tf is the time to travel through one floor with acceleration and deceleration, what we are calling as one floor jump time. One floor jump time is a time which is one floor jump time is time where I am is that time during which actually it will accelerate, come to a constant speed and decelerate and stop at the next floor, while that is that time I am calling as Tf. Tv is the time it does not stop in that floor, passes through the floor. So, that is a constant speed from the floor bottom to the floor top, right. So, if H minus H is a height of reversal, H minus S is the number of floors in which it will travel through constant speed while going up, and that is what I am adding here. So, Tb is the time required at constant speed between floors, right. So, H minus S is the number of floors while going up, it will not stop. So, that multiplied by Tb, and S plus 1 number of floor where it will stop. Now, I have taken the ground floor into account here, both going up and down, because I have taken acceleration and deceleration in the ground floor. Acceleration is while it is going up down, I mean sorry, while going up, deceleration is when it is going down. So, while going down I must consider H minus 1 into Tb, because it will come straight through from H to the ground floor, but the acceleration of the ground floor I have already taken into account, sorry, deceleration of the ground floor, not acceleration, and acceleration of the top floor I have already taken into account in this one, S plus 1 I have already taken care of this one, Tf, in this Tf part, S plus 1 Tf, because what I said is Tf is the one floor jump time. So, it accelerates, constant speed, decelerates. H is the height of reversal. S time this will do Tf, because S stops are there, plus 1 I have added because of the ground floor acceleration, and while coming down there is a retardation. So, ground floor acceleration and retardation is taken care of here in, because I have taken Tf, right, and therefore, it should be h minus 1 Tb and h minus s Tb, because while coming down it will come down straight, it will come down straight. So, my round trip time will be summation of all this. Now, these ones are just known from manufacturer's data, it has to be known, or typically this is known how much time does it require for a person to enter, because this is q number of person, Tp is one person entering the time required for one person entering the lift, and time required of one person to unload from the lift or get out from the lift, and this is door opening and door closing, again manufacturers will provide them. The only thing I got to know is S, and obviously Tf I will have to calculate out from the contract speed, and acceleration time also will be given. Manufacturer might supply depending upon height, because if the height is known, constant speed is known, then I can find out V is equals to u plus Ft. Either time of acceleration must be known, or I must know, I must know, because V is the constant speed given. Usually this is 0, from 0 it starts, or I can assume V by 2 is the average velocity, but again if I want to find out the distance, floor height, then S, the time required, I need the time, I require the time. So, time of acceleration must be known to me, or distance of acceleration must be also known to me. Normally the manufacturer will provide at what rate does it accelerate, or time of acceleration is how much, that should be available to us, right. So, then I can find out Tf, I can find out Tv, obviously contract speed. So, if I know the flow rate, I can simply find out flow rate if I know. So, this is how it is. So, Tf is the floor jump time, etc., etc. Now, I can define Ts. See, where I have S involved, this is S, this is S is involved, and S is involved here. So, S multiplied by all the term related to S I can actually find out. How do I find out? See, this will have S into T0 plus Tc plus S into Tf minus Tv, right, S into Tv. So, coefficient of S is nothing but To plus Tc plus Tf minus Tv, let me call it as Ts, right, and Tf is there somewhere, Tf into S here, Tf was also there. So, this is T0, yeah, Tf I already. So, you can see that Tc T0 T minus Tb. So, this is I am defining as Ts. This is Ts is the time, which is in time unit, is the coefficient of S in this equation, coefficient of S into this equation, coefficient of S into this. Tb is the height, floor of the height divided by contract velocity. Tb is the height of the floor divided by contract velocity, right. Now, yes, standard flow rate, V is the contract speed. One assumes that these two are same, or take average of the two, as T loading or T or whatever it is, some I think I should have used a different notation, Tp plus Tu divided by 2, or or Tp, call this as Tp, maybe call this as T unloading, T loading or something like that. I used T something, I use some terminology earlier, whatever it is, this could be either same, or I can take average of the two, So, the point remains is to determine S and H, right, S and H. Now, S I can determine heuristically, I can determine S heuristically. How do I determine heuristically? Let us determine S I can determine in some manner. Now, S depends on what? S depends on probable number of stops, right. Now, if I find a person in ith floor, let us say, then ith floor will be a stop. So, for a passenger in ith floor, S is ith floor or 1, S is equals to 1, S is equals to 1, because S is number of floors. So, if I have, first thing is I want to find out the probability of finding, because I am looking at expected value, the mean value, probable number of stops, probable, I am using the terminology. So, supposing I have got a person out of Q person in some floor, then probability of finding one person is 1 by Q, 1 by Q, probability of finding a person in a floor is 1 by Q. Now, it will not be a, see basically I am trying to find out probability of finding a person in one floor, second floor, third floor, etc., and if I if I sum up all of them, then I will get the probable number of stops. Let me just tell you, it can be written like this: probability of finding a person in first floor multiplied by 1, S will be equals to probability of finding it out in first floor plus P2 into 1 plus P3 into 1, etc., Probability of finding in the floor, if I find one person, then I will have multiplied by 1. So, that will be S will become 1. Probability of finding in the second floor multiplied by 1. Now, this probability of finding a person in a floor would be given by population in that floor divided by the total population in the building to be served by the lift. Probability of finding, probability of so population, so it will be related to the population. So, if I know the population in ith floor divided by sigma pi, which is the total population to be served, this is the probability of finding one person in ith floor, because all of them will be boarding, all are going to the office, all sum of pi peoples are going to the office. So, if P1, if I know the population in first floor divided by total population, that is the probability of finding a person in first floor. Now, I am trying to now finding out joint probability of finding all people, at least one person from all the Q people boarded in ith floor, at least one person, you see it is at least one person, which means that rest of the Q minus 1 may not be belonging to ith floor. So, how do I find it out? I first find out probability of not finding a person in that particular floor. So, 1 minus pi divided by sigma pi, that is the probability of not finding a person in that floor. This to the power q is probability of not finding any person in that floor. That 1 minus that will give me the probability of finding at least one person. You see, I am looking at probability of finding at least one person, I might have more. Now, then I should find out probability of not finding any person in that floor. 1 minus that probability is the probability of finding one person, one or more person in that floor. Do you get the logic? I think it is convincing, the logic is convincing. So, probability of at least finding one person in the floor is 1 minus probability of not finding any person in the floor, and this is how, this is the logic, heuristic logic we built up. So, S will be basically sum total of all this, because I said this probability multiplied by 1 plus for first floor, ground floor, etc. So, I will have, this will be sum total I going from 1 to n number of floors, and this would be n floors are the n floor above the ground floor, n floor above the ground floor, right, n floor above the ground floor. So, 1 minus pi divided by sigma pi to the power q, that will be S, that will be S. right, that will be S. So, I think the slides now, we can look into the slides, we can look into the slides now, look into the slides. So, if I have n floors, that should be summed up for all the floors, that should be summed up for all the floors. That I said that I should sum up for all the floors, I should sum this up for all the floors, and if you sum up you get it this. So, this is what is S. I think we stop here.